basically reflections. I just want to give you a little bit of notes about what a transformation is. Okay, so it is an operation that maps a pre-image onto an image. Okay, so you're taking a pre-image, mapping it onto a newer image. Now we have three types of transformations. Okay, one is a reflection. Yeah, pre-image. Okay, one is a reflection. Shh. Reflections are like a flip. So you're flipping your image over a line. Okay, so this one is like a flip. Okay, our next one is a rotation. Okay, so a rotation, you're turning your pre-image around a certain point. Okay, so rotation is a turn or spin. The last one is a translation.
Man, I knew it. I knew that one.
Okay, a translation is a slide. So you're sliding your figure along a given line. Okay, so below I do have those three different examples here. So in number 1, 2, and 3, we want to see what transformation is happening from the lighter flag to the darker one. Okay, so our lighter flags are the ones on top. The darker ones are the ones on the bottom here. So for this first one, I'm going to pick a point on our pre-image. Okay, I want to find that same point on our image. So that's right here. Now to get from that point on the pre-image to the image, all it did was move down and to the right. Okay, so it's actually just sliding along that line. So since it's sliding along that line, this one will be considered a translation. Okay, the next one, number 2. This one, I'm going to pick this point at the upper right-hand corner. Okay, that same point is over here now. Okay, so what I'm doing to get to that newer point is rotating around that center point that I drew in. Okay, so it's turning around that center point there. So since it's turning, this is a rotation. Okay, the last one, again, picking my point. I'll choose this one for this picture. It's same point in our image. Okay, it is just flipping over a certain line to get that point. Okay, that would be this line right here. Okay, it's flipping over that line. So this one is a reflection. Okay, so those would be our 3 examples for our transformations. So that's what they kind of look like here. Now the lighter flag that we were working with is called the pre-image. Okay, so that lighter flag is the pre-image. It's your starting image. The darker flag is called the image. Okay, so the image is your ending figure. Okay, the image is your ending figure. So these are rigid transformations because they keep their size and shape. Okay, so they do keep this same size and same shape. Since they keep their size and shape, they are also called isometries. Okay, so these are also called isometries because they do keep that same size and that same shape. Okay, questions on a little bit about transformations before we move into reflections. Okay, so we're going to look more specifically at reflections. Okay, again, we can also call these flips because we're flipping our pre-image over a line. Okay, those are transformations. In a line of reflection. Okay, so you do need this line of reflection in order to reflect. Okay, so it has to reflect over a specific line. Now again, the point before your reflection, that is called the pre-image. Okay, and the point after you do that reflection is called the image. Okay, so the pre-image and the image are the same distance from the line of reflection. Okay, that is why you have a ruler. Okay, so this is why you have a ruler. Your pre-image and your image are the same distance. So we're actually going to measure out those points and make sure they are the same distance. So that's what we're doing in this first example down here. We're taking this triangle and we're going to reflect it over this line of reflection. Okay, so for this one, that line is your line of reflection. Now I'm going to label each of my vertices. Okay, so this first one here, I'm going to label A. Then I have B and C. Okay, so I'm going to take my ruler. I'm going to use the centimeter side so that I can be a little bit more exact with my measurement. Okay, so I'm going to do A first. We're going to see how far away point A is from that line of reflection. Okay, so it's about 3 and then 4 by millimeters. Okay, so I'm going to scooch this over to my line of reflection then. And I need to measure out that same distance on the other side. Okay, so I'll go to 3 centimeters and then 4 millimeters. Okay, and make that point right there. Now, our reflected point, we label as that letter, but with this prime symbol. So it looks like an apostrophe, and we call that A prime. Okay, that's your reflected image. So I'm going to do the same thing with point B. So I'm going to check the distance from point B to our line of reflection. And I see it's at about 7 millimeters. So I'm going to scooch over here, measure out 7 millimeters, and make my point. Okay, so this point now is point B's reflected image, so we label it B prime. Okay, same thing with point C. Okay, point C again, about 7 millimeters, so scooch it over here. So I have point C right here, that reflected image of it, so we'll label it C prime. Then I can connect all of my points using my straight edge. Okay, and that gives me my reflected image. Okay, you can see it flips over that line. Okay, questions on how I did this one? So you are just measuring from your point to the line of reflection. Go that same distance from your line of reflection to your new prime coordinate. It's not super bad.
Equals x2 minus x1 over 1 minus 2.
All right, then moving on. Now we're going to do reflections on a coordinate grid. Okay, so this time you don't need the ruler to measure out. To draw your lines, you do. But you don't need it to measure out between your point and your line of reflection. So in example 3 here, we are going to reflect over the y-axis. So what I like to do is use a highlighter. Okay, I'm going to use a highlighter to draw in my line of reflection so I know exactly where it is. So since it is the y-axis for example 3, I'm going to highlight that y-axis. That's my line of reflection. That's the one I need to see how many units my points are away from. Okay, so here, starting with point G. Point G is 1 unit away from that y-axis or line of reflection. So I need to go 1 unit in the other direction. Okay, so point G, that reflected image, G prime, is right there. Okay, next I'm going to do point F. Point F is 1, 2, 3 units away. So we'll count 3 units again on the opposite side of that line of reflection to make F prime. Okay, then point H is 2 units. So again, go 2 more units to make H prime. Okay, then all we have to do is connect our points. Again, I'm going to use my straight edge here. Okay, and then I have my reflected image. Now, I also am going to have you write down those coordinates. Okay, so don't just write down your image with the points. I also want you to identify those prime coordinates. So G prime. Okay, if I start at the origin here, I go right 1, and I go up 1, 2, 3, 4. So G prime is at 1, 4. Okay, F prime. I need to go right 1, 2, 3, and up 1, 2, 3, 4, 5. And then H prime, from the origin, I go right 2 and down 2. Okay, again, I do need you to write out those prime coordinates. Okay, it is easier for me to grade on quizzes and tests, 1, because then you have those coordinates down and I can see that you were actually finding those coordinates. And then I can just look at your picture to make sure you have it similar to mine. 2, when we get further into this chapter, you will be doing multiple transformations on the same image. So you need to write down the prime coordinates to get the double prime coordinates. Okay, so you'll have to use those prime coordinates you write down to transform your figure again. Okay, so get in the habit of writing down those prime coordinates right away. Make sense? All right, we're going to do the next example. Okay, so example 4, we want to use x equals 1 as our line of reflection. Do you know if that is vertical or horizontal? X equals 1.
Vertical.
It's vertical. Go over to where x is equal to 1. That's right here. All of your x values are equal to 1 if you keep going up and down. So x equals 1 is a vertical line right here. Now this is one where it does help if you have a highlighter. Okay, it does help if you have a highlighter. Okay, so you can identify that line of reflection a little bit easier. So now I'm going to reflect each point over that line. So point G is 2 units away from my line of reflection. Okay, so I need to go 2 units again away from that line. So that'll be G prime. For point F, that is 1, 2, 3, 4 units away from that line of reflection. Okay, again, we're not doing the y-axis, we're doing the line that I highlighted. Okay, so counting 1, 2, 3, 4 units further from that line. That is F prime. Then H is 1, 2, 3 units from that line of reflection. So we'll go 3 more units on the opposite side to get H prime. Now, just like before, we can connect all of our points. To create our image. Now again, I want to write out those prime coordinates. Okay, so G prime. You need to start at the origin to label your coordinates. Do not start at your line of reflection in the x-axis. Start at the origin. Okay, so from the origin, G prime is 1, 2, 3 units to the right. And up 1, 2, 3, 4 units. So that point is at 3, 4. Point F prime. Okay, again, starting at the origin right here. It is 1, 2, 3, 4, 5 units to the right. And 1, 2, 3, 4, 5 units up. Okay, then H prime is 1, 2, 3, 4 units to the right and 2 units down. Okay, so again, make sure you are writing out those prime coordinates as you go. Okay, questions on example 4. All right, for 5. For 5, you're reflecting in the line y is equal to 2. Is that vertical or horizontal? Well, if x equals 1 was vertical, what is y equals 2? Horizontal. Okay, so y equals 2 is a horizontal line. So I'll draw in my line of reflection with my highlighter. So I'm going to use that line to reflect that pre-image. I want you guys to do that part, then label your coordinates. Okay, so reflect that pre-image. Reflect that pre-image. Create the image. And then write out your prime coordinates.
Yes. I don't know what this one's from. Oh my gosh. This is mine.
I don't want your sass today.
I'm really confident today. I was hoping my I followed classes yesterday doing the decimal.
Stop it.
How do you know where to live?
Sorry, Steve.
Just the Scooby Gang guy in his bag. If your other friend teaches you what sign next to no, it's not. So go on. Yeah, reload it. And then you have to go like 4 if you cut it. Yeah, so it goes. No. Today's so dry. Corey
All right, so if you're finished, I do have the answer up on the board. So your triangle should look similar to mine. I do have my prime coordinates labeled off to the side, so don't forget to do that part. Make sure you labeled those correctly and you got the right coordinate. That's how you label image. So you take your original, which doesn't have anything, and it goes to a prime. So that's why, so this is like F prime. So that's what that apostrophe stands for. All right, questions on number 5. All right, so before we do number 6, coming back, doing our notes. Before we do number 6, I want you to look at the table below. So in this table, it tells you how to change your coordinates if you're reflecting in the x-axis, the y-axis, or the y equals x line. Okay, so if you are reflecting in the x-axis, your original coordinate is right here. Okay, this is your original, your pre-image. To change your coordinate, all you have to do is take the opposite of y. Okay, so taking the opposite of y. So an example, if I have 2, -1 as my coordinate, okay, to reflect it in the x-axis, our x value stays the same, so it'll still be 2. Our y value, you need to take the opposite of. So instead of -1, it will be 1. Okay, so you just take the opposite of what it was originally. In the y-axis, again, you have your original coordinate here. That's your pre-image. To change to your image, this time you're taking the opposite of your x value. Okay, so again, if I have 2, -1 as my original coordinate, to reflect that in the y-axis, we take the opposite of our x value. So the opposite of 2 would be -2. And then our y value stays the same. So it'll still be -1. Okay? In the line y equals x, this line is the diagonal line through the origin with a slope of 1. Okay, so that's this diagonal line here with a slope of 1. Okay? To reflect in that line, you will take your original coordinate, so again, 2, -1, and all we have to do is interchange x and y. So we just have to flip-flop those two values. Okay, so if I have 2, -1, I'll have -1, 2 as my image coordinate. Okay, so all we have to do is flip-flop X and Y to reflect there. So now that we have those rules, we can do example 6. So in number 6, we have quadrilateral ABCD with the given coordinates. We want to reflect in the line y equals x. So again, that line is the diagonal line through the origin with a slope of 1. So I'm going to still highlight that line of reflection. Okay, so I'm going to continue with the slope of 1. So it should hit each and every single corner of that box there. Okay, same thing in our negative right here. Okay, this is my line of reflection for y equals x. So now, if you haven't yet, I want you to plot all of our pre-image coordinates. Okay, so point A is at 1, 1. So right 1, up 1. Point B is at 3, 2. 3, 2. Point C is at 4, -1. And point D is at 2, -3. Okay, so this is my pre-image. So this is my original, the one I have to reflect. So now, to reflect this, I'm going to find all of my prime coordinates using my rule below right here. Okay, so all I have to do is interchange x and y. So for A prime, I need to flip-flop these two values. Now when I do that, you're still going to end up with 1, 1. Okay, for B prime, switching my x and y values here, we'll end up with 2, 3. C prime, again switching, so -1, 4. And D prime will be at -3, 2. So I can find each of those prime coordinates. Now I can plot those on my coordinate grid. So A prime is at 1, 1. Okay, so it's still right there. B prime is at 2, 3. Jack. B prime is at 2, 3. C prime is at -1, 4. And D prime is at -3, 2. Okay, after I plot each of those points, I can connect them. To create my image. So if you were to fold these two over that line, they would map out onto each other. Okay, so we do have that reflection over that line. Questions on example 6?